Breaking news from deep space. A strange new object has entered our solar system. And something isn't right. It's moving faster than expected. It's accelerating against gravity. And it just turned bluer than the sun itself. But here's the twist that's shaking the astronomical community to its core. NASA has delayed releasing high-resolution images of this object, just as new data revealed it may have maneuvered on its own. Welcome to today's special report on 3I Atlas, the third known interstellar object ever observed after Oumuamua in 2017 and Borisov in 2019. But this one is different. Different enough that Harvard astrophysicist Dr. Avi Loeb went on national television and publicly said, "It maneuvered. That's not normal. That's not natural." And according to multiple observatories across the world, it also brightened by a factor of 5 and radiated wavelengths bluer than the sun. Today we investigate the unfolding mystery behind 3I Atlas, why NASA has refused to release its highest resolution images, and what it could mean for the future of science, and possibly even human civilization. Because by the end of this video, you'll see why some experts are asking whether we're witnessing the first controlled probe from outside our solar system. Stick around, because what happens next will blow your mind. If you're watching this and you've been tracking the 3I Atlas story, comment below with your thoughts. And if you're new here, welcome. Make sure to subscribe for live updates on this cosmic investigation as it unfolds. Imagine standing in front of a live 3D map of the solar system, the planet's orbit in perfect elliptical loops, humming along the ecliptic plane. Now zoom in. An unknown object enters this plane from deep space, coasting along with a strange smoothness. This is 3I Atlas. First detected by the Atlas Survey project in early September 2025, the object was initially catalogued as a long-period comet. Its velocity, however, told a different story. It was moving at over 150 kilometers per second, 3 times faster than the fastest man-made object ever launched from Earth. NASA's JPL confirmed its hyperbolic trajectory. The object wasn't coming back. It wasn't from around here. It was interstellar. Normally, comets from deep space follow loose, flaring paths, shedding mass violently as they approach the sun. They develop long tails of gas and dust, visible evidence of their death throes. But 3I Atlas didn't. Even as it approached perihelion on October 29th, passing 203 million kilometers from the sun, observers noted no tail, no coma, no flare, just 7 sharp jets and a fuzzy core. Let's walk through what happened next, and why astronomers and skeptics alike began asking questions. October 29th, 2025, 3I Atlas reached its closest approach to the sun. November 6th, 9th, 2025, a sudden 5-fold increase in brightness. November 7th, 2025, Dr. Avi Loeb appears on Newsmax and says this: "It maneuvered." That moment changed everything. Up to that point, the mainstream narrative was quiet, technical, and conservative. Now, with a respected Harvard astrophysicist declaring non-natural behavior, national media took notice. In parallel, the Virtual Telescope project in Italy, led by Dr. Gianluca Massi, was live-streaming updates. Amateur astronomers began comparing notes. Spectral data began circulating, revealing something even stranger. The colour signature of 3I Atlas Gephi was bluer than the sun. This is where it gets weird. Under normal conditions, comets get redder as they heat up. Their dust and gas scatter sunlight, shifting their visible spectra into red or orange hues. But 3I Atlas shifted blueward, meaning it was emitting shorter wavelengths of light than the sun itself. How is that possible? The sun emits light at around 5,800 Kelvin, peaking in the visible spectrum. For an object to be bluer, it must be emitting more high-energy light, either from being hotter or from an entirely different process. But 3I Atlas wasn't hotter. Thermal readings suggested it was cooler than 5,000 K. So where was the blue light coming from? Was it a chemical anomaly? Spectral data suggested a nickel-rich composition, with an unusually low iron content. That's not typical of comets, which tend to contain silicates, carbon, and ices. And here's another issue. No debris field, no comet tail. Not even faint traces visible through powerful instruments like the Las Cumbres Observatory Global Telescope Network. What emits blue light, doesn't burn up, has jets, no tail, and moves without slowing. Some began to whisper what many feared to say out loud. What if it's artificial? This brings us to the central controversy now brewing on Capitol Hill. According to multiple insiders, the Mars Reconnaissance Orbiter passed within range to capture high-resolution images of 3I Atlas in early November, specifically using its high-rise imaging system, capable of detailing objects as small as 30 centimeters from hundreds of kilometers away. But as of late November, no images have been released. Public requests under the Freedom of Information Act have been denied or delayed. And in a recent hearing, US Representative Anna Paulina Luna directly questioned NASA representatives, asking, "If you already have the images, why are they being withheld?" No clear answer was given. NASA cited data processing and public release protocols. But the timing raised eyebrows. Just days after Loeb's It Maneuvered interview, the image release stalls. Congressional interest spikes. Speculation grows. And into this storm, one line from Dr. Loeb stood out. "We may not be the observers anymore. We may be the observed." Now let's go back to the sky and ask, where exactly is this object? On the night of November 9th, if you use software like Skylive or Stellarium, 3I Atlas appeared between the constellations Virgo and Leo, gliding silently along the ecliptic plane. That's a significant detail. Most random interstellar objects cut through the solar system at strange angles. Remember Oumuamua's steep entry? But 3I Atlas approached almost coplanar with the planets. Its orbital path mirrors the layout of the solar system. According to calculations published by the Galileo project, its trajectory is suspiciously stable, with non-gravitational acceleration pointing in the same direction as the jet-like emissions from its surface. Translation: it looks like something is pushing it from within. And now, as it heads toward its closest approach to Earth on December 19th, telescopes from Italy, Chile, and even the private sector are frantically attempting to get high-resolution imagery. But so far, the best shots we've seen are grainy, pixelated, frustrating. NASA, silent. ESA, cautious. Harvard, asking louder questions every week. Let's get one thing clear. Objects in space don't just move on their own. They obey gravity. They follow the physics we've confirmed for centuries. But in early November 2025, 3I Atlas changed direction. Slightly, but undeniably. And it didn't decelerate, it accelerated. This acceleration wasn't explained by gravity. There were no nearby planets pulling it. No radiation pressure from the sun intense enough to produce the magnitude observed. And yet it moved, just like Oumuamua did, but even faster. At roughly 150 kilometers, 3I Atlas is now hurtling through the inner solar system, and the trajectory calculations from NASA JPL's Horizon system suddenly had to be revised. Why? Because the object was no longer where physics predicted it should be. Let's look at the math. If a comet-like body accelerates, it usually does so due to outgassing, the release of vapor jets as sunlight heats surface ice. That causes motion. But here's the catch. For 3I Atlas to show this acceleration, it would have to eject 5 billion tons of material in a perfectly directed jet over just a few days. There's no tail, no debris, no vapor, nothing visible to support that level of thrust. According to Harvard's Dr. Avi Loeb, the motion is consistent with internal propulsion, like a probe adjusting its course, and the orientation of the movement, in alignment with solar orbit plane, makes this even harder to ignore. Using filtered imagery from the Virtual Telescope project, several independent astronomers identified 7 symmetrical jets emitting from the fuzzy core of 3I Atlas. That's already unusual. But the geometry, even more precise than expected. 3 jets emanate from one side, 3 from the opposite, and 1 directly vertical. Some compared the structure to a triad thruster layout used in early satellite prototypes. And then something even stranger happened. Infrared telescopes, including those operated by the Spitzer follow-up program, reported no infrared emissions strong enough to indicate heating. No thermal plume, no hot exhaust. It's moving, but not burning. Emitting jets, but not warming up. As one scientist wrote anonymously on the Galileo Project Community Forum, this is either the most thermodynamically efficient object ever recorded, or it's something else entirely. Typically, active bodies in space, even natural ones, emit a wide array of signals. Dust grains, gas molecules, thermal energy, but 3I Atlas is nearly silent in every spectrum that matters. A team at the Green Bank telescope scanned for anomalous radio emissions. Result: no artificial signals, but a sharp cutoff in radio reflectivity, as if the object was absorbing incoming waves rather than scattering them. Likewise, infrared telescopes in Chile and Italy reported low thermal albedo, meaning 3E Atlas, appears cooler than its surrounding environment, even while emitting visible blue light. That's not just odd, that's unheard of. Even asteroids reflect heat. Even icy comets show a thermal signature. But 3I Atlas, it's like it doesn't want to be seen. On November 11th, something unprecedented happened. Congresswoman Anna Paulina Luna delivered a short but pointed statement during a House Science Committee meeting. We've received expert briefings indicating that images of 3I Atlas have not been publicly released. That is unacceptable. Her staff had already contacted NASA's Mars Reconnaissance Orbiter team, specifically asking about the HiRISE data. NASA's response: still under analysis. No timeline, no samples. But internal sources, reportedly from the Jet Propulsion Laboratory, suggest the data was ready. The delay? Political. And it wasn't just Luna. Several senators from the Space Oversight Subcommittee began circulating a draft proposal, a call to declassify all near-Earth object imagery within 7 days of capture. No exceptions. So far, the bill has not passed, but the pressure is mounting. And the public? Getting restless. If all of this is true, why isn't it all over the news? Why aren't we seeing front-page headlines reading, Harvard astrophysicist says object maneuvered? Or, NASA accused of hiding interstellar images? Well, there may be 2 reasons. Scientific caution. Most mainstream media wait for peer-reviewed consensus. Institutional control. Some suspect a quiet protocol to delay anything labelled potentially artificial until thoroughly vetted. As one former NOAA space weather analyst put it, there's a blackout playbook. We used it during early solar anomalies. You delay, you minimise, you outlast the public interest. But the internet doesn't forget, and the amateur astronomy world is wide awake. Right now, citizen observers using backyard telescopes and image stacking software are sharing raw footage on Reddit, Discord, and X. Many are now coordinating a global female alignment watch, leading up to December 19th, the day 3I Atlas makes its closest pass to Earth. Here's what we know about that date. December 19th, 2025, 3I Atlas will be just 0.24 AU from Earth, about 36 million kilometers away. That's roughly 90x closer than it was at perihelion. And if it's artificial, we might finally see structural detail. Multiple observatories, including the Very Large Telescope in Chile, the Las Vegas Galileo Project site, and even private optics groups like Unistellar, are organising a continuous monitoring campaign. They want to catch structural breakup, possible. Staging event, multiple objects separating new jets or light bursts, radar signal reflections that might indicate internal geometry. And in the meantime, one phrase is beginning to spread online: don't look away this time. Because the fear isn't just that this thing might be technological. The fear is that it might be watching us back. What if 3I Atlas isn't solid? What if the object passing through our solar system, accelerating, emitting jets, turning blue, is actually hollow? In this segment, we explore a radical theory gaining traction in astrophysics and fringe science circles alike: the hollow shell hypothesis, and what it could mean if the strange structure we're observing isn't natural, or even entirely there. On November 14th, the Galileo Project Forum published a speculative analysis by amateur physicist Ian Thorson, suggesting that 3I Atlas's brightness curve and spectral reflections could be consistent with a thin, hollow structure. His reasoning: the visible luminosity is unusually high relative to thermal output. The jets appear to emerge from the edges, not from a central core. Light distortions around the body suggest possible concavity or surface curvature, not typical for comets or asteroids. He proposes, if the object is hollow, the mass-to-momentum ratio changes. That means smaller jets could still cause major accelerations. especially if stabilized in real time. That would explain the movement without requiring tail vaporization. The implications could be an interstellar probe, lightweight, maneuverable, could contain instruments, data, or passengers, could be ancient, hollow because it's been stripped by time. Is this wild speculation? Maybe. But here's where it gets interesting. Recent telescope footage, including captures from the Virtual Telescope project, show inconsistent outlines. Observers in different locations, Italy, California, Chile, reported seeing slightly different silhouettes of the object on the same night. That shouldn't happen. Space is consistent. So why are different observatories reporting different shapes? Some propose atmospheric distortion. Others hint at something far more sci-fi, a cloaked or refractive shell. If 3i Atlas has a mirror-like outer structure, it could bend or scatter light depending on the angle, creating the illusion of shapeshifting. Or it's designed that way. But now we move from theory to proposal. On November 17th, Dr. Avi Loeb published a paper draft proposing an intercept trajectory for NASA's Juno spacecraft, currently orbiting Jupiter. Here's the plan. On March 16, 2026, 3i Atlas will pass near a corridor of space within potential reach of Juno. If Mission Control initiates a burn by January 2026, Juno could intersect the object's trajectory, or at least capture long-range magnetometer, plasma, and visual readings. This could be our only chance to directly observe the object before it leaves the solar system, Loeb wrote. NASA's response? None. Yet. But the Galileo project team is actively calculating timing windows. If this goes forward, it could be the first time in history humanity sends a probe to intercept an object. That might be artificial. Of course, it depends on public pressure, budget approval, and time. And time is running out. Here's what makes all of this even more compelling. 3i Atlas isn't the first visitor to behave this way. In 2017, the object known as 1i Oumuamua entered the solar system, made a hyperbolic arc, accelerated without a tail, and then vanished. No coma, no debris. A strange shape, likely flat. It reflected sunlight oddly, and its acceleration couldn't be explained by gravity or outgassing. Sound familiar? It should, because 3i Atlas is following a near-identical pattern. Except it's bigger. 4.5 kilometers, it's faster, 150 km/s, and it's bluer than any known object at this temperature. This is why scientists are paying attention, because this time we're watching in real time. Now let's zoom way out. On August 15, 1977, the Big Ear Radio Observatory recorded the most famous unexplained signal in history, the WOW signal, a sharp narrowband burst lasting 72 seconds. Its source? Somewhere in the constellation Sagittarius. 3i Atlas? Its entry vector in September was only 9 degrees away from that very region. In celestial terms, almost overlapping. Now, correlation isn't causation, and space is huge. But for theorists like Loeb, the coincidence is enough to ask the question, could this object have originated from the same system? Is 3i Atlas a reply, a second mission, a long-delayed follow-up? We don't know, but we do know this. 2 interstellar objects in under a decade, 1 strange radio signal, and now an object that maneuvers, glows blue, and hides its tail. What are the odds? You might be wondering. Why isn't everyone in science jumping on this? The truth is, many are, but few are talking. Most astronomers operate within funding structures tied to government agencies. And those agencies are under intense scrutiny right now. NASA has to defend why the high-rise images are still unreleased. The ESA has to explain why its December optics campaign has been reduced in scope. The Galileo project operates independently, but even they are facing questions from Congress about where their data is going. And so, while citizen scientists are energized, some professionals are stepping back, at least publicly. But in private forums, encrypted Slack channels, and closed seminars, 3i Atlas is being discussed, heavily. And on December 19th, that discussion may break wide open, because when the object passes closest to Earth, we may see a split A flash, a course change, or silence. Whatever happens, humanity will be watching, some with hope, some with fear, and some just waiting for confirmation of what they already believe, that we are not alone. On that day, 3I Atlas will pass closer to Earth than any other known interstellar object in history. Just 36 million kilometres away, and for the first time ever, dozens of telescopes around the world, public, private, amateur, military, will be watching the same small point in the sky, with one question on their minds: what happens now? According to the latest trajectory data from the NASA JPL Horizons system, 3I Atlas is travelling on a stable outbound path. But stable might not mean what we think anymore. Why? Because this object has already violated Newtonian expectations. It changed course, it accelerated, it emitted structured jets, and it still shows no sign of traditional comet behaviour. Here's what scientists are preparing for on December 19th. Structural imaging. Can we finally see the object's true shape? Light fluctuations. Will the jets activate again? Radar bounce back. Any geometric patterns or hollow behaviour? Fragmentation or release? Will something separate from it? If any of those happen, the mystery deepens. But if nothing happens, if it just flies past and disappears, then the mystery becomes even deeper. Right now, a coordinated observation effort is underway. Multiple global institutions have confirmed campaigns. Las Cumbres Observatory, using their robotic network to photograph in multiple light bands. Very Large Telescope, Chile, targeting the core with adaptive optics, Harvard's Galileo project team, aiming high-res live streams and spectral filters, Virtual Telescope Project, Italy, publicly sharing real-time views, Unistellar, France, USA, mobilizing amateur astronomers globally with connected telescopes. Add to that rumours of military satellites and even private space imaging companies like Planet Labs quietly redirecting assets. Everyone wants a piece of the sky, everyone wants to know, before it's too late. So what are the most likely scenarios? Let's walk through the top 4. 3I Atlas splits apart as it passes Earth. This would mirror the behaviour of Comet Shoemaker-Levy before it hit Jupiter. Except there's no obvious gravitational stressor here. If it splits without a cause, that might mean it was designed to. One or more new jets activate. A directional burst could alter trajectory again. If this happens, we, may finally be able to map out internal propulsion logic and test the hollow shell theory live. Smaller objects are released. This is the drone pod theory, that the main body is a carrier, not the payload. If tiny symmetrical satellites emerge, it changes the game. No change, no data, just continued trajectory. This is the worst-case scientific outcome because it gives skeptics ammunition. But paradoxically, it also matches behaviour that isn't natural. Because in space, doing nothing, when everything says you should, is also a signal. One haunting question that scientists are preparing for: what if 3I Atlas just vanishes? Oumuamua's brightness dropped off sharply after 2017. It was never seen again. What if this object follows the same pattern? Some suspect 3I Atlas will become invisible after the flyby, especially if its jets turn off, or if it activates some kind of optical deflection. If so, this may be our one and only window, a few minutes of high-resolution data that we cannot afford to lose. That's why dozens of observatories are setting their clocks. December 19th is not just an event, it's a deadline. Regardless of what happens on December 19th, one thing is clear. Humanity is not prepared for interstellar object tracking at this level. Currently, no international protocol exists for rapid trajectory, publishing high-resolution data sharing, coordinated object response across agencies, intercept mission deployment. Some are now calling for the creation of an interstellar early response program, combining NASA, ESA, Harvard, and even private space companies like SpaceX and Blue Origin to respond to fast-moving anomalies. Dr. Avi Loeb's Galileo Intercept proposal, March 16th Juno Bern, may become a blueprint for future missions. If 3I Atlas is artificial, or even just unusual, it could spark a new space policy era. And now the question that refuses to die, and grows louder with each anomaly: are we the ones being observed? Dr. Loeb has said it plainly. We may not be the observers anymore. Consider this. The object behaves precisely but without signals, emits light but no heat, avoids tail formation, aligns with the ecliptic, our solar plane reflects light that exceeds solar blueness. Came from a direction near the WOW signal. This isn't random, and now it's watching Earth from just 0.24 AU away. So maybe the truth is this: we've spent centuries peering into the sky, but what if someone, or something, was finally peering back? So what happens now? We wait, we watch, we prepare. Because on December 19th, we may witness the final piece of a puzzle that began decades ago, in 1977 with the WOW signal, in 2017 with Oumuamua, and in 2025 with 3i Atlas. And if nothing happens, that silence might be the loudest message of all. If you want to follow this story as it unfolds over the next few weeks, subscribe to this channel and turn on notifications. We'll be covering every update from Harvard, NASA, the Galileo Project, and citizen observatories as the December 19th flyby approaches. Leave a comment below. What do you think will happen? Will it split? Will we see the jets reactivate? Is it natural or technological? I read every comment. And your theories matter, because this time we're all in this together. Until next time, keep looking up.